Okay, hi there. Welcome to Chapter 6. How cool are we? Okay, so we're going to go over some of the vocab for Chapter 6. And don't worry about it because we're going to go over it again when we get to it. But I'm going to try and make it as clear as possible. Okay, so this video will be in a couple of parts so we don't overdo it like I did on the last one. Okay, so chapter vocab. What is the altitude? Anybody remember what the altitude is? I'm going to show us. Okay, so the altitude is something that comes from the vertex of a triangle straight down to the other side, and it is perpendicular to the other side. And if I could draw, am I good? Yep. Okay, and it comes from the vertex. It does not have to be, A, it doesn't have to be inside the triangle, and B, it doesn't have to be the perpendicular bisector of the other side. It just has to be perpendicular. So this is the altitude, which is also called the height. Okay, this is the height and the altitude. Then an angle bisector, I think we already know. The angle bisector cuts an angle into two congruent angles. That we know. Now, this one, the centroid, the circumcenter, and the incenter, and the orthocenter. They are centers of a triangle. I bet you never knew a triangle had so many centers. And we're going to talk about them later. There's a silly sentence to remember how to figure out what each one is. And I'm going to introduce that in a little while. Okay, so the centroid is where the medians meet. Okay, the medians of a triangle connects a vertex to the midpoint of the other side. Doesn't necessarily have to be straight. The orthocenter is where the altitudes, all three altitudes in a triangle meet. The incenter is the angle bisectors where they meet. And the circumcenter is where the perpendicular bisectors meet. Don't worry, we will be going over all of that again. Circumscribe is basically to draw a circle around. Okay, so circumscribe, I'm going to attempt. Promise nothing. I'm going to circumscribe a circle around this triangle. Whee! And I didn't really get it, but that's as close as I'm getting. Okay, so circumscribe, draw a circle around. All right, concurrent lines. You know that the prefix con means with? So concurrent lines and rays and segments are just lines, rays, and segments that meet at a point, and that's called the point of concurrency. Okay, so the point of concurrency is where the concurrent lines, rays, segments meet. Indirect reasoning is annoying, and we're gonna look at it for 30 seconds and ignore it for the rest of our lives. A median is something right smack down the middle of a figure. Okay, I always think of it as the concrete barrier in between the highway that's that divides the highway into each way. Okay, and a mid segment we're going to discuss very soon. A mid segment connects the midpoints of two sides of a polygon to each other. Usually you're going to see it with triangles. You're actually also going to see it with trapezoids. All right, so that was a quickie for the vocab. All right, and the concurrency, that just means they meet at a point. And the other circle things we're going to get to, so we're not worrying. Okay, so let's take a look at mid-segments. Okay, the definition of a mid-segment, it's a segment that connects the midpoint of two sides of, in this case, a triangle. You're also going to see it in a trapezoid. Okay, so notice here, DE, DF, EF, they are all mid-segments of triangle ABC. And what we'll learn is the mid-segments connect the midpoints of two sides. They are parallel to the third side and half its length. All right, we're going to do a bunch of that, so don't worry about it. Okay, so that's a mid-segment. It connects the midpoint of two sides of a triangle. So like D and E. D is the midpoint of AB. Notice the congruency marks here. E is the midpoint of BC. Notice the congruency marks here. Okay, it connects the two midpoints. So let's say DE was 5 units long. That would be our hint that AC is 10 units long, because this mid-segment is parallel to the third side and half its length. All right, mid-segment theorem. Here we go. If a segment joins the midpoints of two triangle sides, then the segment is parallel to the third side. If a segment joins the mid-segments, yeah, I'm speaking well the English. If a segment joins the midpoints of two triangle sides, then the segment's length is 1/2 of that third side's length. Okay? That's just what I said. So now you've heard it again and seen it in print. All right, we're going to prove the mid-segment theorem. And notice here I used 7 steps. On the next page, you're going to see what they did. It's a little confusing, but whatever. Okay, so we're given that AD is congruent to DB. We're given that BE congruent to EC. So since this part and this part are congruent, that has to be the midpoint. Since this part and this part are congruent, D has to be the midpoint. All right, so we stated our given. And now if you notice, angle B, which triangle is it in? It's in this big triangle, and it's in this smaller triangle. So it is equal to itself. That's the reflexive. We use that next. Then we have the segment addition postulate, just to show that AD plus DB equals AB, and BE plus EC equals BC. All right, and then we use some substitution. Okay, so AB is equal to 2 times AD, BC is equal to 2 times BE. Okay, so therefore they're in proportion. So we have now the triangle similar by the side, angle, side similarity theorem. Okay, I'm going to show you the other sides. Okay, because it matches this side, same angle, this side. Since the sides are in proportion, the triangles are similar. Okay, so we have the side angle side similarity. And now we know that angle A is congruent to angle D, because in similar triangles, all the angles are congruent. I hope you remember that from the last section, because we said that a lot. Okay, and now A and D are also corresponding angles. They're angles in the exact same position on a different line. Therefore, these two lines are parallel, because if corresponding angles are congruent, the lines are parallel. Okay, I'm going to stop for a second so you can take that in. Okay, so feel free to pause the video if you need to look at this one for a little while. And I'm going to show you how they did it. It's similar to what we did, but a bunch more confusing, in my opinion. Okay, so we did what we did and we did fine. Okay, now, problem number 1 here says AD is a mid-segment of a triangle. Okay, mid-segment, so think of what we just learned. We learned that it's parallel to the third side and half its length. Okay, and it's parallel to side FE, which has endpoints at 4, 3 and 4, -5. Okay, which pair of coordinates are possible endpoints of AD? Now, so we know it's got to be parallel, so it's going to be a vertical line. Okay, and if it's going to be a vertical line, then the X values are equal. Okay, so that's one hint. And it's going to be half the size of FE. What's the size of FE? It goes from 3 to -5, which is 8 units long. I'm going to mark that so we don't forget. Okay, so this is 8 units long. So our mid-segment has to be parallel to FE and 4 units long. So let's look. Okay, here the X's are not the same, so this one's gone. Here the X's are the same, and let's see the distance. I'm going to plot 2, 1 and 2, -3. 1, 2, 3. All right, and I'm going to connect the dots. This one has good possibilities, right? This is 8. How many units is this? 1, 2, 3, 4 units, and it's parallel. So, oh no, I don't want to write that there. All right, so this is 4 units right here, and it's parallel. So this one has good possibilities so far. Here, the x's are the same, but look at the y's, 3 and -5. That's a distance of 8. So this guy's gone. Here, the x's are the same, but that's a distance of 2. So this guy's gone. So here are our coordinates. Okay? Those aren't necessarily the only coordinates, but those are the coordinates out of those choices that worked. Okay, so you see it's a vertical line because this is a vertical line, so they're parallel, and it's half its length. Okay, so we're good. All right, so we're going to do one more, and then we're going to pause this video, and I'm going to go to another one. Okay? Oh, and this is what they did. Okay? And they got the same thing we did. Okay, the answer is B. As mentioned, the mid-segment is parallel to FE. FE is a vertical segment. Since its x coordinates are the same, a mid-segment also has half the length, yada yada, ooba dooba. That's what we just did. All right? Let's see. Okay. Oh, I meant to cover this up. Cover your eyes for a second. Okay, so identify the parallel segments. Notice QR is parallel to GH. Oh, I did. Okay, I'm giving it away. All right. Hang on, bear with me. I just gave you that one. Okay, now look at QS. QS. What is it parallel to? Never touches, never meets. Parallel to and half its size. That looks like FH to me. What does it look like to you? Okay. And now let's look at the next one. Okay, RS. What is RS parallel to? GF, right? Parallel to somebody's girlfriend. Okay. Notice the we have the longer sides here. These are the mid segments. These are the longer sides. Okay, so let's stop here.